This is a second lecture on an introductory lab here on measurement systems and especially using Arduino in the DSC lab. As I mentioned before, the intent here is to get everybody leveled up. A lot of people have experience using Arduino, maybe even advanced knowledge on using this device, but the intent here is really just to get everybody leveled up and ready to do some of these experiments and to become familiar with using the Arduino, especially as a measurement system, and then later as a as a control system, because Arduino devices were developed as microcontrollers, not really as data acquisition systems, as we've discussed in the previous lecture. But they can become part of one, and if you configure it, as we will in a follow-up lab, where we combine it with Python to control and to acquire data. Arduino does use a different language and different software, more C-like, C++. So part of this lab is really to get everyone acquainted with that. The Arduino itself is, again, a circuit board. It has an AVR microcontroller. The Arduino itself, this microcontroller was developed somewhere around, say about 1996, and the Arduino product was started by an Italian company somewhere around 2005. So, it's about 20 years old. What made it unique, the creation of the AVR microcontroller, was the ability to have a device that was relatively easy to program. What Arduino did, when it was put together, was really to put it on this board, allow it to be accessed via USB. It has power on it. It has a clock to run the microcontroller, and so on. The key elements of the Arduino, again, allows you to interact well with the physical world, right? It allows you to use it as a controller to build all kinds of devices. There's headers that allow you to connect, to has analog to digital converter, so it has analog pins, it has digital pins, and it also has communications channels that allow you to communicate with some of these modern sensors that we've talked about. So part of what, again, we want to do with this lab is to just get everybody comfortable with using one of these devices. I've put here, you can find all of this. There's so much information online and so many nice tutorials that if you feel uncomfortable and just need more knowledge, that's the best way to go about doing that. But be mindful that the Arduino has limitations on what it can do, and so that's part of what we want to learn how you want to learn how to use it properly. You need to power it, obviously. So when you're connected via the USB, you can it's being powered this way, right? If it's connected directly to your computer, say through a USB cord. If you sever that, you can still power it. There's a power port here. You can give it external power, so it doesn't have to be always connected. We will always have it connected with the USB for our projects, because we as I said, we want to use that serial port to not only send data but also to retrieve data that's collected by the Arduino and by sensors connected to the Arduino. So we have all these pins that we want to learn how to use. Be mindful also, especially some of these the currents that the Arduino can sync. It doesn't have a lot of current capability, and also when you're driving outputs, those can only be done via pulse width modulation and so on. We'll learn some of those things as we go forward. Okay. Again, a lot of information that you can find online, not only at the Arduino website, but at many different. There's so many nice YouTube videos on how to get started and so on. The other thing is making just for any data, using any kind of computer-aided data acquisition system is and setting up circuits, right? Whether it's on a breadboard or if you're building something, just being mindful of the right connections. Starting off with grounds. I know everyone always feels like, well, I know what a ground is, but be mindful of the fact that there's different types, right? There's a circuit or common, right? There's an earth ground and there's a chassis ground. And the common is usually actually represented by this guy. And usually that means it's sort of floating, okay? A battery terminal, the negative terminal on a battery is actually more floating than any of these others. So if you were to put that, it's actually more like this. And a lot of sensors and so on have common grounds. Earth ground is usually represented, something like this, right? Like, so if you were thinking about putting the ground connection at your home into the ground, it usually is represented by this symbol. And finally, a chassis ground, like what you might have on an oscilloscope or something, would be the one that we almost always draw this way with the three little lines. So, whenever, sometimes again, we default to this guy, but be mindful of the fact that you might have different kinds of grounds. There's a saying that a friend of mine taught me, who was a double E, all grounds are not the same the world round. At any rate, where you see this, especially, and I remember this is something that you might see in other kinds of device descriptions, you could have sources now. So those, let's say you have ground connections, but you could have also sources. You might have floating sources. A battery might be something like this. It's floating. It's not connected to the earth, right? Whereas you might have a grounded source that's connected maybe either to the chassis or to earth ground. So be mindful of the fact that you could have different sources as well, right? Power supplies. A battery is not necessarily grounded, and you might want it to be floating, right? So again, just some things to be aware of when you're putting circuits together, right? So part of what we want to do in these first experiments is put together these simple types of test circuits to make sure things are working. So I ask you in pre-lab, for example, to run the classic LED blink, where you can connect up an LED. By the way, some of the newer or even compatible kind of Arduino devices might actually have an LED that's already pre-configured on the device itself. But connecting one here, again, the ground terminal that's indicated on the Arduino itself is not necessarily even a chassis ground, right? So be careful. It could be floating. And so like if you're connected to a battery pack, that's a floating ground, and so on, right? So just be aware of all these things. So even just putting together something as simple as this, you can learn a lot about how to make it work right, and so on. Okay. The other thing that's important to remember about Arduino is that you do have to give it software. You have to embed software on it. You always use and you download this IDE from Arduino, and it's free, and allows you to put these, and they call them sketches, these little programs that run in Arduino. Learning the format of those is important. So this one here shows you that all Arduino sketches or programs, if you like, have a setup part and a loop part. When you flash, if you like, a program onto Arduino, it runs the setup, and then after that it starts running in a continuous loop. So everything that you want it to be doing after it starts and turns on, it'll be in this loop, and the setup here only runs if you restart it, so to speak, right? So you put setup code in here, you put continuous running code, and every Arduino program looks like that, as you might know. A lot of nice examples already built into this program when you download it. So like the blink, I think the blink is already in 01 basics there, and there's a lot. So you want to learn about how to measure a voltage, it's you just go down here into File, Examples, and you go to Analog, and it'll download a code. So you don't really have to start anything from scratch. You can just kind of download it, look at it, make some changes, and again, you can always find a lot of really nice guidance online. So the blink code looks something like this, right? It has a setup part that all it does is assigns it to there's a pin mode that's given to, and actually this is the LED built in, and it sends that it defines that pin as an output so that it can blink to that pin, and then all it does is run in a loop, and it continuously turns it on and off with a delay. So again, study this code just to kind of get comfortable with it, to get accustomed to what an Arduino code looks like if you're not familiar with it. Here's what the analog input example looks like. A little bit different. Again, it's still you're assigning an output to a certain pin. You're also assigning some variables to whatever pin. Like so here, I'm saying I want to put an output to the 0th pin. And then again, you can study the code here. It sends an output to a particular, sorry, it reads from a particular input here, and it also is actually writing to the LED. Again, you'll need these to understand these examples because you'll be using these in the upcoming lab. I have some copies of some cheat sheets and so on that I downloaded. You can find these, I found this at SparkFun, a nice site for buying stuff and learning. There's a lot of code that we get from them for using certain kinds of sensors, but you can find information on specific programs. Of course, the Arduino website itself has a lot of good information on any of the commands that you might want to read. So let's say you wanted to if you wanted to learn more about the digital read or any of these other functions for doing stuff or writing code, you can go to Arduino and there's a reference page and you can find more information and examples on how to use this.